we're going to factor this completely. Not grouping. We're supposed to recognize that it's something we could substitute in. So excuse me, let's try this. We'll say, how about this? X is equal to d squared. And then we'll replace, we'll say 2 times x, but it's d to the fourth, so x squared, minus 13, and we can just say x minus 45. Okay, and then I think to myself, I can't factor out that 2 because 13 and 45 are odd, but I might be able to do the ACB method. 2 times 45 is 90, and then it's supposed to add up to negative 13. Oh, that's negative 90, sorry. It's supposed to add up to 13, so I'm going to skip a couple. I know it's not 1 and 90. I know it's not 2 and 45. Well, I know it's not 10 and 9 either. How about 15 and 6? No, 15 and 6 don't work either. Let's see, what else could I say? I know it's not 30 and 3. Maybe I should have done this more. 18. How about 18? We'd say 18 and 5. There we go. 18 times 5 is 90. And 18 plus 5, if the 18 is negative, I get a negative 13. So now I can say 2x squared, negative 18x plus 5x minus 45. And just for review, notice that the beginning and the end are the same. No difference there. And then also notice that the middle is the same. It's just that down below it's in two pieces. Negative 13 is the same thing as negative 18 and positive 5. Okay. And now it is a little bit like grouping because I have, for these first two, I'm going to say 2x will come out, and it's x minus 9 left inside. And then we'll say, it looks like a 5 will come out, so 5 comes out, and I have x minus 9 again. So I know that x minus 9 is one of my factors. And also 2x plus 5. And it didn't ask me to solve, so I won't set it equal to 0 and solve for the x's. But that is factored now. And if I multiply it, oh wait, well, hang on. I forgot to substitute the d back in. So hang on. Instead of saying x, I'm supposed to say d squared minus 9, because remember x is equal to d squared. And then I'm supposed to say 2d squared plus 5. Well, 2d squared plus 5, that's not going anywhere. But wait, I just about forgot a whole new thing here. This is the same thing as d plus 3 and d minus 3, because it's the difference of two perfect squares. This is the sum of not perfect squares, so neither thing there yells to be factored. Okay, now we have it in terms of d. And if I were to multiply that all out, I would get back to the beginning. Or I should. If I don't, something's wrong. But I do. One thing we could do to check it is we could look here and say d times d times d to the second, and 2, by the way, is d to the fourth, right? And then we could also say, how about the last terms? We could say 3 times negative 3 is negative 9 times positive 5 is negative 45. So that checks out too. Now, if we really wanted to check it, we could multiply it all the way back out, but that is the truth.